Hi, this is my soldering fume extractor that I built a couple of episodes back. Today I want to upgrade it so it will serve me even better. The idea is to automatically turn on the fans when soldering fumes are detected and turn the fans off when the air is clean again. Let me introduce the upgrade on a breadboard. The key component is an MQ2 gas sensor. It can detect combustible gases and smoke, which makes it perfect for this project. This chip is an Atmel AT-Tiny85 which controls the whole rig. It reads values from the sensor, and when it detects fumes, it changes the state of the gate to high on this N-channel MOSFET. The transistor turns on and the fan starts spinning, which is indicated by this blue LED. Right now some of you are probably wondering why I didn't use a simple NPN transistor, like for example this BC517. It can handle up to 1 amp and the fume extractor draws up to 0.65 amps when the fans are on. The reason is very simple. During my breadboard tests, the MOSFET turned out to be much more efficient than the NPN transistor. I had a few of those 40N03GP MOSFETs salvaged from old PC power supplies, so I could use them for free. Let's go back to the rest of the components. This red LED is only power on indicator. The fume extractor itself runs on 12 volts, but all other components need only 5 volts. That's why I used a buck converter, which takes 12 volts on the input and converts it to 5 volts on the output. I want to place the gas sensor over the fans because fumes will go up and it will be easier to detect them. Let's produce some fumes by melting a piece of solder and we'll see how this upgraded fume extractor works in practice. The fumes are detected, our fume extractor turns on and the blue LED lights up. A few moments later, the fumes are gone and the fans are turned off, just like we wanted. All this magic is driven by the Arduino code, running on the Atmel AT-Tiny85, so let's take a peek. This section defines 3 variables. The first 2 of them are simply your own Arduino pin names. The last one resets the sensor value so you can be sure you won't get any false readings immediately after turning on your circuit. This line defines pin 4 as digital output, which means it can take one of 2 states, high meaning on or low meaning off. This piece reads the sensor value, which determines the last part. If it's higher than 570, pin 4 goes high and turns on the MOSFET, which in turn switches on the fume extractor and the blue LED. If the previous condition is not fulfilled, the MOSFET is turned off and the fume extractor stops. As you can see, the code is very simple and does the job pretty well. In the next episode I will finalize this project, so consider subscribing if you don't want to miss it. If you like this video, please share it with your friends to help me create more content for you. Thanks for watching and see you next time.